right, I'm ready. So, welcome everybody. I'm Arnoud Vermeer. I work for LeaseWeb. I used to be in the CDN team, so I actually do know how to build a CDN. The talk today is about IPv6. I got a perfect introduction. IPv6 is not working right now in this office or in this venue. And I'm going to talk about living on IPv6 for a week and how that went. So before I get started, I want to basically pull your knowledge or the general knowledge of the building. So I'll start with a small quiz. Who knows when IPv6 was introduced? Anybody? Who thinks it's 5 years ago? Who thinks it's 10 years ago? All right, some people. Who thinks it's 15 years ago? All right, some more people. Who thinks it's 20 years ago? All right, you're actually right. Introduced in 1995. They saw this coming a long way. It's over 20 years since IPv6 was introduced. And we'll talk about how it's going. So, another quiz. When did we run out of IPv4 space? And this is in the regional registries. Any idea? Is it in the last 2 years? Who thinks it's in the last 2 years? All right, some people. Who thinks it's in the last 5 years? All right. Who thinks it's in the last couple of months? Nobody. Oh. All right. We ran out of IPv4 space in Asia Pacific in 2011, in 2012 in Europe, in June 14th in Latin America, and in 2015 in America. It's not going so well. There's one missing. Where can you get your fresh IPv4 space? Like brand new. Anybody know? Africa, yes. Africa has only 1/8 left, but it's only 7.8% used. So go to Africa, start a new internet company. It's the right thing to do. All right. So with some general knowledge, let's see how we're really doing on the IPv6 stuff. So this is a great graph actually published by Google about how much IPv6 deployment or use they actually see. And they've divided it in two different graphs. One, IPv6 adoption in general. And you can see it went up from hardly anything to already 16% or going up to 18%. So it's not nothing anymore. If I gave this talk 5 years ago, it would be nearly nothing, but now it's already 16%. So let's look at some statistics. How is the Netherlands doing? The Netherlands doing 9% of this country has IPv6 natively in their home. 9%. And we ran out of IP space. When? Oh wait, in 2012. What are we doing? How are we doing it? That's another question. So, is it this bad everywhere? So you see the graph, and how greener it gets, how better the deployment. And if you look to our southern neighbors, Belgium is actually doing amazing. They have 50% coverage. What is different? Why are they so rolling out IPv6 so much more than we do? Actually, it's just because there's two Belgian providers, Telenet and Belcom, and they decided to roll out IPv6 to all of their customers. Actually, there's 3 providers in the Netherlands that are currently rolling out IPv6. Is there anybody who knows? Access for All, yes, they've been doing it for a long time. KPN is actually rolling out on all new customers and Ziggo because they ran out of IPv4 space. And this is the thing, right? If you want to add more subscribers and you don't have IPv4 space, either you can buy it from a third party, and it will cost you, at this point, I heard, about 12 euros per IP. So, or you can deploy IPv6, which is basically free. So, the plan. I'm going to live off IPv6 for a week. Let's see what happens. Can I do my job? Can I live my life? Can I do it at home? Can I do it at work? We'll see. So why would I do it? For science. But not only for science, I actually want to challenge myself. I want to actually find out what works and what doesn't work. And I want to challenge LeaseWeb, the company that I work for, because I think we have a lot of work to be done. So how do you live on IPv6 only for a week? Well, on my laptop, it's as easy as just turning IPv4 off. But I have a lot of more devices than just my laptop. I have my phone, and actually, I can connect it over Wi-Fi, and then I can not give it an IPv4 address, but I can't really turn off my carrier IPv4 internet. It's just not doable. So the only thing I can do is switch off mobile, which at that point, I'm also not reachable anymore. This is the only phone I have, so my plan for going IPv6 only is going great. I'm going to be able to communicate so much. So what I did at home, I created I skipped over one important part. I'm actually somebody of those 9% of the Netherlands who have native IPv6 at home. Without that, this talk would not have been possible. Or the talk would have been very easy. Living with IPv6, it's not possible. Bye. So I created an IPv6 only network just to try it out, and I connected my phone, my tablet, whatever peripheral I had, my TV, all the things to this IPv6 only network, and I just started using it like every day. And very soon my girlfriend got very frustrated because this is basically what happens. This sums up basically your experience if you go IPv6 only. A lot of things don't work. Everything breaks in unexpected ways. My favorite pastime, Reddit, is not available. The good thing is I had a lot of time to fix this. The other part of it actually is there's a lot of stuff that does work these days. I'll come to it in a bit. So I had my home situation basically figured out. I just have an IPv6 only network, and that works, or it doesn't, but we'll find out. But in the office, I noticed we get native IPv6, so I was, yes, I'm going to be able to do this here. But then I noticed they only push IPv4 name servers. So as soon as I turned off IPv4, I could not resolve any domain name anymore. So of course, the challenge, I can work around this. I can just manually configure my IPv6 name server and continue, but I wanted to do better. So I contacted my local sysadmins, and I reached out and I asked them, hey, can you please add an IPv6 name server so I can continue my experiment? And this was their response. IPv6 is not fully implemented, and that's the reason why we do not use it. We're actively disabling IPv6 where we find it. Also, DHCP for servers is not desired. All your servers should have a static IPv4 address. Please configure your servers accordingly with IPv4. Thanks, guys. So I did continue with my experiment. I statically configured my own name server and I moved on. But yes, there's things to do. What actually works, to my surprise, since I tried this experiment a couple years ago and nothing worked basically. But what does work is a lot of my favorite pastimes. Google, I can search for everything, it just works. Netflix, I can watch all the movies, so I could spend a lot of time doing that. Wikipedia, it's cool. And anything behind Cloudflare CDN, basically, which is quite a lot these days. But my favorite part is I could search for everything I wanted on Google, and then I would find the page, and I would click on the page to go there, and it breaks every time. So my living on IPv6 was use the cached mode that Google hosts. And of course, it's not a way to live, so how do we fix all the other stuff? I did want to live on IPv6 only for a week, but I did not want to not live. So I thought of a way to basically fix it. So the way I only fixed it is I added a NAT 64 device. And it's basically, in my case, it can go up to a carrier-grade NAT router that you buy and you put in a data center if you're a Ziggo or a UPC or whatever you want. Or it can go as small as I had a Raspberry Pi and I installed Linux on it, and there's an open source tool called Tega, and it does IPv6 to IPv4 translation. I'll explain how that works in a bit. But basically, I have a laser pointer, right? So this is me, lonely in IPv6 only land, only surfing, well, Netflix and Google. And I want to actually get out to IPv4 land again. So what I did, this is a Raspberry Pi. It has Tega on it, and I have slash. So all right, IPv6 has 128 bits of IP space, and usually what providers do is they give you /64. So if this is my IP address, half of this, actually here, is mine. I can do with whatever I want. So what I did, and what is generally the thing they do if you do 6-to-4 translation, is you take 96 bits of your 64 bits, so up until here, and you use that to encode all of the IPv4 addresses in your IPv6 prefix. So actually, you have the decimal numbers here, and you translate it to hexadecimal, and you put them over there. And then you have that one host in your house, in case my Raspberry Pi, and it and you route all the traffic to the Raspberry Pi, and it sees your request. It sees, oh, this is the special prefix, and it takes the last couple bytes, and then it makes a request to IPv4. It transfers the data back, and then it encapsulates it in IPv6 again and sends it to me. So this is kind of cheating, but this way, I was living IPv6 only, but I could still work. So that's what I did. If you have some spare time and you want to check it out, it's really fun to play with. Oh yeah, and the other part is it's not only NAT, so what I explained is the NAT. The other trick is the DNS. So for IPv4 only websites, there's only an A record in your DNS, generally. But for IPv6, you want a quad A record, so A. The way to get around it is if there's a special, there's actually really cool tools. Google has a NAT 6-to-4 IPv6 range. If you use that as your DNS resolver, and they only find an IPv4 range, they will answer with a specific prefix and the IPv4 address encoded in it. So if you have your setup configured correctly, then it will actually work. All right. But I wanted to do something special, so I had my own IPv4 space, and you can configure either bind or unbound or power DNS to basically do the same thing for you. So I set up DNS 6-to-4. And the only thing that does is encapsulate the answer of the IPv4 address to IPv6. So, I have a question for you. This is a question I often ask when I'm interviewing new candidates for LeaseWeb. And I wonder if you know the answer. So my question is, today I'm going to start an internet company, not in Africa, just in Europe. And I only get a /24 and a shit ton of IPv6 addresses. So how can I make my hosting company work? Anybody have any idea? Outsource the problem to someone else. Yes, that's. Okay. Yeah. That's one way. Get the rest of the world on IPv6. That would be the preferred way, but also the hardest.
Let all of your customers use your Raspberry Pi.
Let all my users use my Raspberry Pi. That's one way. It doesn't scale very well, though. But Raspberry Pis are cheap. I could probably send out a lot. No. So what actually? What I actually do? I thought I had a slide here. All right. So what you would actually do is you have the IPv4 only internet, and you have some a load balancer with both IPv6 and IPv4, and then you have your data center, which is only IPv6, and your request comes in as an IPv4 address. Your load balancer terminates your request, looks up, oh, I need to talk to this backend server, and it does that via v6. The whole data center is v6. I only talk to each other in v6. You get the answer back in v6, and your load balancer answers back in IPv4. So this way, you can scale based on host names. So it doesn't have to be in NAT translation where you scale an IPv4 address to an IPv6 address. You can do it based on host names. So now I can retire this interview question because everybody knows the answer, right? Is it clear? And this seems like future, but this is actually how not the LeaseWeb data center. This is how the Facebook data centers actually work. Inside of the Facebook data centers, it's IPv6 only. On the edge is the only part where they have some IPv4 space just to do the NAT translation. And the advantage is you'd migrate to IPv6, and as soon as the deployment goes up, you don't have to maintain basically dual stack. So you don't end up in a situation where IPv4 is broken and you don't notice, or IPv6 is broken and you don't notice. You only have one time the maintenance cost. You run IPv6 only in your data center, and then it complicates, or it makes it a lot easier to run your data center. So basically, I have my IPv6 only space, and I wanted, basically I explained in the beginning of the talk is how my normal life, like at home, looks like on IPv6. But of course, I want to do my work as well on IPv6. So I challenged myself, can I provision a server with IPv6 only? And to do this, let's get a random server in the data center. I asked my lovely networking engineers over here for some IPv4 space in Iraq. They delivered, and I was able to get the CentOS installation over IPv6. It all worked. Great. So next step, I wanted to bootstrap Chef on it. So we use Chef internally to provision our machines. So I do the knife node bootstrap command, and I see it reaching over SSH to my server, and then it tries to download the Chef binary over IPv4. So I created an issue on GitHub saying, guys, whoops, please fix it. And I'm not a bad guy. I did this a while back. I basically told them, like, hey, I have this IPv6 only node, and I'm trying to reach this download site, which is basically S3. I have this Chef version, and it's unable to download over IPv6. So what do you do to test? You just look for the DNS record, and it pulls you to Amazon, but you didn't configure Amazon correctly. The only thing you need to do, or I first just reported the bug, and then I gave the answer to them because I'm helpful. So I told them, okay, you're using Fastly, and I had contacts at Fastly, and I said, can you enable IPv6 for them? And they said, sure, but they only have to request it via the support. So I told them, just ask Fastly, and they'll enable it for you. So that's the website taken care of. And then the download site Actually, it's super easy to fix. The only thing you need to change is the CNAME that you have for downloading the thing, and then add dual stack in front. And then ta-da, it has IPv6 space. And within some knowledge, they replied saying, okay, any thoughts? And this is August 2016, a year ago. And to this day, they have not changed the CNAME, and they have not asked their CDN to enable IPv6. Let's get back to presentation. That's not what I want. All right, well, doesn't matter. So, I already told this. So, to conclude, basically, IPv6, this is what your future is going to look like. Your provider is going to run out anytime in the next Ziggo ran out IPv4 space. They're going to deploy IPv6 to you, and they're going to provide some sort of translation service. So either we switch to IPv6 and we can fix this, or we're screwed. That's the end of my talk.
First question, right?
Well, just out of curiosity, supposing you have a 40-hour work week, how many hours of that did you really work? And how many hours did you spend fixing or not doing things because you couldn't?
I didn't do the 40-hour continuously. I worked, basically, I did 1 day of IPv6 only, and then I noted all the things that were broken, submitted all the pull requests, changes, all the things, and then basically re-enabled IPv4. But initially, if I would have done it the whole week, I would have worked like 30 hours not. Yeah, I mean, most of our servers are able to get IPv6, so I could just use that. We use a gateway server to reach our servers that has v6, so from there I could actually route over v4 to all the other hosts and then roll out v6 as I went. It's doable, but it's all a workaround. Yeah.
All in the back, and I have one here.
Yes, I have a question. Sorry, yes. So you're saying that in the Netherlands, ISPs are changing over probably to IPv6 only in the near future. I guess that's a big step, at least for power users. I guess that won't be acceptable, at least at this point. I guess in mobile world, we're all used to net-only connections, but fixed, it's still pretty common that everybody at least gets one IPv4 address. So when do you think providers will really go and take this step, that just general customers will not get an IPv4 address at their homes anymore, but just IPv6 with some trickery around it to still get IPv4 connections working?
So, okay, that's a good question. Currently, Ziggo is deploying carrier-grade NAT today. So if you sign up for Ziggo today, you get v6 only. You might get an IPv4 address, but it's a 10.something RFC 1980 space. If you ask them and you have specific requirements, you say like I want to run a web server and it needs to be reachable over IPv4, they'll switch you back. But new deployments, they're done. KPN rolls you out with dual stack. Access for All currently rolls you out with dual stack, but it's a matter of time until their pool basically exhausts. I know Comcast in the US is rolling out carrier-grade NAT, IPv6 only networking. I know T-Mobile in the US, all their phones are IPv6 only with carrier-grade NAT. Well, $10 an IP. I mean, that's if you write that off, that's quite a cost, and IPv6 is free. So carrier-grade NATs, they pay for themselves pretty early. Sorry.
So why wouldn't the carrier-grade net solution then just stick around forever if this works?
Because not only are we running out of IPs in the consumer side, we're also running out of IPs in the content generation side. So if Facebook wants to get any bigger, they clearly have got their shit together. They only have IPv4 at the edge. But if you want to expand into more markets, then you're going to have to switch eventually. So it's a matter of cost. It becomes too expensive to deploy IPv4 at some point, and that's where the incentive comes from to switch to IPv6.
We have one more question on the other side.
When you were running the 624 translation on your Raspberry Pi, did you notice any overhead, like any additional slowness on the network?
Yeah. Yes, of course. Normally it routes directly to my router, and now it had to go through my Raspberry Pi. And there's a translation step. And there's, it's inside my network. It wasn't that bad, but there was definitely an added delay, like a couple milliseconds. And I have found out I use a Ubiquiti Edge router at home as my main router, and I found out I was being stupid because it just run Debian Linux, and I could not use the Raspberry Pi and just install Tega at my Edge router, and it was solved. But that was basically 20 hours into my Raspberry Pi project.
More questions? Nope. Well, thank you, Arnoud.
All right.